In this video, we are going to learn how to unit test our Spring Boot applications using JUnit 5 and Mockito framework. This is the first part of the Spring Boot testing tutorial series where we will cover different aspects of testing like unit testing using JUnit 5 and Mockito, integration testing where we will test our database layer using test containers. Lastly, we are going to also test our REST APIs using Spring's MockMvc framework. As I mentioned before, this tutorial will only cover the unit testing part using JUnit 5 and Mockito. We are going to use a real-world application I have built in my previous tutorials, which is a Reddit clone application, as an example for this tutorial. If you're interested, you can check out the tutorial on how to build that application in the description section. And as always, you can find the source code and the written version of the tutorial by the first link in the description section. So without any delay, let's start the tutorial. So the first thing we have to do is to download the source code of the Reddit clone application to your machine. You can find the GitHub link to the source code in the description section. So you just have to clone or download this project to your machine. After you downloaded the project, open this project inside the IDE. And the first thing we are going to do is to install JUnit 5 in the application. To do that, I'm going to open the pom.xml file and add a dependency with the name JUnit Jupyter. And at the time of creating the video, the newest version is 5.6.2. And in the existing project, we already have access to Spring Boot starter test dependency, which provides us necessary Spring features to test our application. We will not use these Spring features in this video. We'll be using it in the next parts, but there is one thing we have to observe and change in this dependency. So if I go inside the pom.xml of Spring Boot starter test, we can see that it contains JUnit 4 as the transitive dependency. So as we already have JUnit 5 dependency in our application, this will create a conflict. So to exclude JUnit 4, we can add an exclusion tag to the Spring Boot starter dependency. Once this is done, if you are using IntelliJ, make sure you re-import the Maven projects by typing Ctrl-Shift-O or by pressing the Maven icon on the top right side of the editor. So after completing this, we are through the initial setup of JUnit 5. And now let's have a high-level look at the architecture of our application under test. So this image will show you the high-level architecture of the Reddit clone application. We have our backend application, which is built using Spring Boot with MySQL database, and this backend is communicating with the Angular frontend. If you zoom into the Spring Boot application part, here we are having a three-tier architecture where we have a controller layer, where we have all the REST controllers, which are interacting with the services which are defined in the service layer. These services contains the business logic of the application. So the services inside the service layer are using the repositories which are defined inside the persistence layer. Here is where we are storing the data inside the MySQL database. If we have a look at the package structure, we have divided this into packages controller, service, and repository, and we can see all the classes defined inside these packages. This is a brief overview about high-level architecture of the application. So now let's go ahead and start writing our first unit test. We're going to create a first unit test for the comment service class. This class is responsible to deal with all the business logic for the comments posted by the user. I'm going to show a shortcut to create the test from the comment service class. So if you type Ctrl-Shift-T, then you will see an option to create the test. And if you select the option, you will see a window where you can select JUnit 5 as the unit testing library, and you can also select for which method you want to write the test. Here we have the method contains swear words. Let's select this method and click on OK. And you can see that IntelliJ automatically created the test with a method annotated with test annotation, which indicates the below method is our test case. To make this test executable, we have to mark the class as public, as JUnit expects all the test classes to have public access modifier. Now let's have a look at the method we want to test. The contains swear method, as the name suggests, will check whether a comment contains any swear words or bad language in it. Here we are checking for some random swear words, and if the comment contains any of these words, we are throwing an exception. And if this check is passing, we are returning false from this method. Let's write a test case to test whether a given comment contains a swear word or not. I'm going to name this test as should not contain swear words inside comment. One thing we have to remember is to make your test methods as readable as possible. The user who is reading our code should at least get a high-level overview of what the test does by looking at the name. But due to the Java naming convention, we cannot always write a perfectly readable test method name. Even though this method name conveys its intent, it's better to have a nicely formatted and worded description. For this reason, JUnit 5 provides us with a display name annotation where we can provide a readable name for the test. So now I'm giving a detailed description like test should pass when comment do not contain swear words. The next step is to instantiate the class under test. So if you look at through the comment service class, it has lots of dependencies and almost all of them are classes which are managed by Spring. If you look into the method we want to test, we don't need any of those dependencies inside the class. So I'm going to create an object for comment service inside the test by passing null values as dependencies. And in the next line, I'm going to call the contains swear word method of the comment service object by passing a clean random comment. And now we have to verify that this method returns us the value false or not. We can use the assertions class from JUnit 5 to make assertions about the actual and the expected value from this method. Let's make use of the assert false method from the assertions class to verify the return type. And if we run the test by clicking on the green button to the left side of the editor, you can see that our test should pass. So congratulations, you have written our first unit test. But wait, writing unit test is not about always writing the tests which are always passing. Right? As a rule of thumb, we have to make sure that our tests are also failing if something is wrong in the logic of our method. So for that reason, I'm going to make a small change to the method. That is, I'm going to return the value true instead of false and rerun the test. So now I expect the test to be failing. Perfect. So always make sure that you're writing a failing test first and then make it pass, or just at least make sure that your test will fail when something goes wrong with the logic in the code. Now let's go ahead and write a test for the scenario where we give a bad comment as input and our method throws an exception. As developers, we tend to get stuck into and emphasize only on happy path testing, but it's also important to cover the negative cases. So when the submitted comment contains swear words, we expect the method to throw an exception. So let's write a test case for that. So I created another test with the name should fail when comment contains swear words, and as this method invocation now throws an exception, we can verify this behavior by using the assert throws method from the assertions class. This assert throws method takes the exception class as the first argument, and the second argument we are providing a lambda where we are invoking the method under test. This method returns the exception, so we are going to store it in a variable, and we can access the exception message by using the getMessage method of the exception class and verify it by using the assert through method. If we run this test, I expect it to pass. So yes, indeed, it's passing. That's good. Okay, so till now we have used JUnit 5 built-in assertions class to make some basic assertions. But we can write more readable assertions using the assertj library. Let's add this dependency to our pom.xml and see how it helps us to write better tests. So let's add the dependency assertj core to our pom.xml, and you can re-import the Maven projects using Ctrl+Shift-O. After that, let's open the comment service test to see how we can improve our assertions and make use of the Fluent API provided by assertj. In both the tests, we are asserting for Boolean values using the assert true and assert false methods from assertions class in JUnit 5. Instead of that, we can use the assert that method, which takes in the method invocation, which we have to trigger as an argument. And if we type control space, you can see that we have the IDE support to see which methods we can use for the assertions. As we want to assert that the written value is false, we can select the isFalse method here. Do you agree that this approach makes the test more readable than the previous method? You may or may not agree with me because it's not worth the effort to introduce a new library just for a small case like this. But assertj library shines in the case where we have much more complex assertions, which we will do in the next upcoming videos. But for our second test, we can refactor the assertions for the exceptions by using the assert thrown by method, which takes in the lambda, which contains the method call, and we can use the method instance of to check what kind of exception this method will throw. In our case, it's Spring Reddit exception.class. And finally, to verify the exception message, we can use the hasMessage method. This makes the test more readable, and I'm a huge fan of the Fluent API, so I feel this makes it easy to write clean tests. Okay, so until now we are not testing the functionality which depends on the other classes. So the test we wrote for the contains swear words method is just confined to our class itself. And this method does not contain any external dependencies. So to unit test the functionality which has some external dependencies like the repositories, we can make use of mocking frameworks like Mockito to mock out these external dependencies. So you may ask why to mock out these dependencies? Because as I mentioned before, for unit testing, we have to test the functionality of our class in isolation and without depending on the external dependencies. But as our business logic heavily makes use of these dependencies like mappers and repositories, we have to mock their behavior. We will have a look at how to do this in detail shortly. But for now, let's install Mockito in our project by adding the Mockito all dependency to the pom.xml, and again make sure to re-import the Maven projects using Ctrl+Shift-O. Now let's take a different class as an example. Let's open the class post service, and this class is mainly dependent on the post repository, subreddit repository, user repository, postmapper, and auth service classes. So we cannot really test anything in this method without either mocking or injecting real dependencies into this class. So let's go ahead and create the class by pressing Ctrl+Shift+T and selecting create new test. We're going to write a test for the getPost method. So I'm going to select that method and click on OK. I'm going to rename the test method to something like should find post by ID, and I'm going to also add the display name annotation to make it more readable. And what I want to do here is to create an instance of post service class. And if I just type new post service, you can see that we have an error because we have to provide all the dependencies to the constructor. We can create mocks of our dependencies using the mock method from the Mockito class. So let's define these mocks as the class level variables. And I'm going to create mocks for all the dependencies for the post service class and pass them as constructor arguments. Okay, now if we go back to the post service and observe the getPost method, it's taking an ID as the parameter, and we are trying to retrieve the post by its ID using the findById method from post repository. This method will return an optional of the post object. If there is no object matching this ID, we are throwing an exception, or else we are mapping this object to post response object and returning it back. So to write a unit test for this method, we have to first mock out the behavior of the post repository's findById method. We can do this in Mockito using the when method. So here back in the post service class, I'm going to type mockito.when and pass in the post repository.findById method. And this method will take some arbitrary value like 123L. I'm adding L because it's a variable of type long. Then we have to return an optional of the post object. So to specify that, we can use then return method and pass in an optional of post. So to pass in this object, I'm going to quickly create a post object with some dummy data and wrap this object in an optional and pass it to the then return method argument. So what will happen in the background is if we execute the getPost method, Mockito will return this optional of post object whenever the findById method is invoked. This is basically the concept of mocking. So instead of calling the real method, Mockito will just provide the dummy object we want to continue testing the functionality. So in the next line, we are mapping the post object to a post response object. This is the DTO we are sending back to the client. So let's also make this behavior using the same syntax, when and then return methods. In this case, we need a post response object. So I'm going to again construct a dummy post response object and name this variable as expected post response. So now we have mocked all the external behavior of this method. So let's call this method from our test and store the response in a variable called actual post response. Now we can verify that our expected post response object and actual post response object contains similar values. I'm going to make an assertion for the ID and post name fields. Okay, so now it's time to run this test and see whether they are passing or not. So you can see they are passing. We can also put a breakpoint inside the map to DTO method of the post mapper and check whether the method is really executed or not. So I'm going to run the test again in the debug mode, and you can see that the execution is not stopped at this breakpoint. Mockito completely skipped this method call and mocked the method call by replacing it with the response we have provided. So this is how you write unit tests using Mockito. I hope it's clear for you. If you have any questions, put them on the comment section and I will try to answer them. Okay, now it's time to make some small improvements to our tests. You can see that we are using mockito.mock method to create mock objects. So instead of using this static method, we can make use of mock annotation provided by Mockito. So to use that annotation, we have to add the Mockito JUnit Jupyter dependency to our pom.xml file. So let's go ahead and quickly add that dependency. And now you can enable this annotation in our test by adding the extend with annotation from JUnit and providing the Mockito extension.class as the value to this annotation. So with this, JUnit understands to enable Mockito extension annotations in our tests. Now we have to replace this mockito.mock methods with the annotation. I would like to show you a quick IntelliJ trick here. Normally you will go ahead by editing this code line by line by removing the mock method and adding the mock annotation. But we can make use of something like multi-cursors in IntelliJ by pressing the Shift-Alt-J piece So this will select all occurrences of Mockito.mock method inside the class. So now if you press the arrow keys, you can see that the cursor is moving along for multiple lines at once. So using this method, you can easily edit multiple lines at once. So I'm going to add the mock annotation in the same way. So this change should not have any side effect on our tests. So let's confirm this by rerunning them. And indeed, they are working fine. Now let's quickly test another method inside the post service class. This time we will test the save method. Here you can see inside this method, we are reading the subreddit by its name from the subreddit repository, and then we are mapping the incoming post request to post object and saving it to the database. We can mock the behavior of find by name of the subreddit repository and map method of the post mapper interface in the same manner as we did for the get post method. But the tricky part here is to mock the behavior of the save method. We cannot use the when and then return method sequence here because the save method is not really returning anything in this method. In these cases, we can make use of the verify method in Mockito to check that a particular piece of code is really executed or not. So I'm going to create another test called should save post with the display name annotation, and here I'm going to again create an instance of post service and pass in the mock dependencies, and I'm creating some dummy data required to mock the calls for the subreddit repository and post mapper interfaces. And finally, I'm specifying the behavior of this method calls as we saw before in the get post method example. Now let's call the save method of the post service, and after the method is executed, we can verify with Mockito whether the post repository.save method is executed or not. We can do that by typing mockito.verify, and here I'm going to pass in the object on which we need to do this verification. In our case, it's post repository, and we can specify exactly how many times we are expecting this method to be executed. In our case, we just have one call to the post repository.save method, so I'm going to just pass in the value 1 to the mockito.times method. So once I prepare this object, I'm going to get access to the methods of the post repository, and as we want to verify the behavior of the save method, I'm going to select that method, and as we don't care what kind of object is passed as the input to this method, I'm going to add argument matchers.any post.class as the input to this method. This will inform to Mockito that as long as an object of type post is passed into the save method and it's exactly called one time, I'm okay with it. So let's try to run this method and see if our test is passing or not. So okay, great, the tests are passing. We can also capture the object which is passed into the save method and can assert whether the object which is passed on to this method really matches our expectations or not. We can do that with the help of the class argument captor in Mockito. Let's see how we can do this. Inside the test, I'm going to remove the declaration of argument matchers.any and we will replace it with the argument captor. So first we have to declare the argument captor inside the class. Let's do that by adding a captor annotation. And in our example, we have to capture the arguments of type post object. So let's declare the argument captor of type post and name this variable as post argument captor. Now let's come back to the save method inside the test and add the post argument.capture declaration here. In this way, Mockito will capture the object which is passed into the save object at the time of running the test. And now we have access to this object even after the method execution. So we can retrieve the post object by using post argument captor.getValue, and let's do some assertions on this object. The value for the ID field should be same as the value we declared in the dummy data. So I'm going to add an assertion that it's going to be, and I'm going to add the same assertion for the value for the post name variable. So now let's run this test again, and as you can see, our test is passing. So we have covered lots of unit testing and mocking concepts in this tutorial. Let's wrap this up by refactoring our tests by using the JUnit lifecycle methods. Inside the test, you can see that we are creating an instance of post service method for each class. To avoid that, we can use the lifecycle method of JUnit 5 called before each, which will execute a particular piece of code we want before each test in the class. So let's create a method called as setup and annotate it with before each. And I'm going to remove the post service class instantiation from the couple of test methods we have and pull it into the setup method. In this way, we can avoid the code duplication and rely on JUnit to provide the required objects at the time of test execution. Let's rerun the tests again to make sure everything is fine. And yes, indeed, the tests are passing. In this tutorial, we are going to learn how to test our data access layer of the Spring Boot applications using test containers. This is the second part of the Spring Boot testing tutorial series. As always, you can find the written tutorial and the source code in the first link in the description section. So if you check the architecture diagram of the Reddit clone application, it is divided into 3 layers. We have the controller layer where the REST controllers are stored, and in the service layer we have the business logic of the application which are stored in the services, and in the persistence layer we have code for all the repositories which is storing the data into the MySQL database. So as part of the first video, we have covered the unit tests which are mocking out the interaction between the service layer and the persistence layer using Mockito, and we cannot use any kind of mocking in the tests which we are writing for the persistence layer, because we want to actually test the interaction between the persistence layer and the database. So it doesn't make any sense to mock out the behavior, to mock out the interaction with the actual database. So to test the persistence layer, we are going to first use an embedded database called H2, and after that we are going to see what are the limitations for using the embedded H2 database and how we can replace this embedded H2 database with test containers. If you don't know what is test containers, don't worry, we will cover this soon in the tutorial. So the first thing we are going to do is to install the embedded H2 database into our project. We can do that by adding the following Maven dependency into the pom.xml file, and make sure you re-import the Maven projects by typing Ctrl+Shift+O. And after that, I'm going to create a test inside the test package. Inside the Java folder, I'm going to create a new package called as repository. And inside this package, I created a new class called as user repository test embedded. As we are using the embedded H2 database, I named this class as user repository test embedded. And inside this class, we have first the data JPA annotation. This is the annotation which is provided by the Spring Test Framework. This, as you can see, it is including many other annotations, especially the auto-configure data JPA, auto-configure test database, transactional, auto-configure cache. So it auto-configures all the database and the JPA related functionalities out of the box into our Spring context. And in the next line, we have the active profiles test. I've created another profile called test, where we are storing the information about the embedded H2 database. We have the driver class name as the H2 driver and the data source URL. As we are using an embedded database, I'm going to provide the following URL, and the username and password I'm going to leave it as defaults. And lastly, the Hibernate dialect property I have provided as H2 dialect. So if we go back to the class, I have first auto-wired the user repository into the test class, and then I've created the first test, should save user. Here what we are doing is just creating a user object, just nothing fancy here, and I'm trying to save this user object to the repository. The save object returns the object which just saved as the return type. So I'm going to store this return type into another variable called as saved user. And after that, I'm going to make use of the assert.js libraries assert that method. I'm going to pass in the saved user to that assert that method. And what I want to do now is compare this object with the actual object we have provided to the save method. So we have to recursively compare all the fields whether they are equal or not. So for that, I can use the using recursive comparison method of the assert.j. So what it will do is it will take each fields one by one and compare it against each other. And for the user ID, we cannot provide any actual user ID here because this is auto generated by the database, usually auto incremented. by the MySQL database. So we have to ignore this field in our comparison. So for that, we can use the ignoring fields method and pass in the name of the field as the parameter. So that is user ID. And once this is completed, we can just make our assertions that this saved user object is equal to the user. So this is one way of testing the interaction with the database. And the other way is to pre-populate the data without manually creating the user object and saving it to the database. So the Spring Test Framework provides us with an annotation called as SQL. So what it will do is it will take the name of the SQL file as the input to the annotation. And in this SQL file, we're going to actually insert the values, like insert the data into and in this SQL file, we're going to insert the data to whatever table we like. So we can check this test data SQL file under the test Java resources folder. And here you can see that we just have a plain old insert statement. At the time of the test startup, Spring will have a look at the test data SQL file and it will execute this SQL file and save the data automatically. And inside the test itself, we are just querying the user repository by the username. And if you go back to the test data SQL file, I have configured the username as testuser_SQL, and we are finding the user by the same name. So this method should return an optional of user, and in the next line we are asserting that this optional of user is not empty. So let's try to quickly run this test and see what happens. If you have a look at the logs which are generated by the Hibernate, save users through a SQL file, we don't see any insert statement, but we just see the select statement which is generated from Hibernate. Whereas if you go into the should save user test logs, and you can see that it is first inserting the data into the database, and after that we are doing the assertions based on the return value of this method. So we wrote our first repository test using the embedded H2 database, and as I mentioned before at the beginning of the video, there are some limitations in running our tests against the embedded database. Because in the Reddit clone application, we are using MySQL as our production database, and it is always advisable to run our tests against a real database, as we are testing our code in a similar environment to production. So the main pain point for using a real database for unit tests is maintenance, right? Ideally, the tests we are writing will be executed in a continuous integration environment like Jenkins. So installing a database on the CI environment and maintaining it is a very tedious process. So to solve this problem, we can make use of the test containers. So test containers is a Java library which provides us a way to create lightweight instances of the common databases we use in production. It mainly uses Docker in the background to create a container, and we can use the database which is running inside the container to run our unit tests. So test containers not only supports a database, but anything which can run inside a Docker container. So if you want to write some Selenium tests, you can make use of test containers to quickly spin up a web browser, or if you're using any other external dependency to your application, you can create a container and make use of it in your project. So before we start working with the test containers, just make sure that you have the Docker engine installed on your machine. I'm using a Windows machine, so I've installed the Docker using the Docker desktop for Windows. So just make sure to install this, and after installing the Docker engine, we have to add the test containers into our Maven project. So for that, I'm going to add the following test container dependency to our pom.xml. So using this dependency, we're going to create the test containers which runs the MySQL database inside the container. So I'm going to create a new test inside the repository package called as post repository test. Using this class, we are going to test the database interaction which are performed through the post repository interface. Inside the test class, I'm going to annotate the class with data JPA test annotation. So as I mentioned before, this will spin up a Spring context which contains all the database related and JPA related functionalities. And followed by this annotation, we are going to add the test container annotation provided by JUnit 5. This annotation will enable the test container functionality in our test class. So after that, we are going to use the auto configure test database annotation. This is usually part of the data JPA test annotation, but as we are using a MySQL database from the test container, we have to explicitly specify that the Spring context should not replace the default data source. And inside the test, we can initialize our MySQL database container by creating an object of MySQL container class, which takes the name of the latest Docker MySQL image as the constructor parameter, followed by the database details and user credentials. After initializing this object, we can start the container inside the test by adding a container annotation to this field. This is also a JUnit 5 annotation. So when the time of test startup, JUnit 5 will automatically start the container for us. After that, I'm going to auto-wire the post repository inside the test class. And now let's create our test method called should_save_post. And in here, I'm creating a post object. And as we did previously for the user repository test, we're going to take the return value of the save method, store it in a variable, and after that we are going to use assert_js using comparison method to check if the actual post object contains same field values as the expected post object. So now let's go ahead and run this test. So the tests are passing, and if you check the logs of the tests, you can see that the MySQL container is started, and once the database is initialized, our test started the execution. And the whole test took around 19 seconds. If you're running the test for the first time on your machine, it will take a bit more time as it will try to download the Docker image from the Docker registry. So in this way, we can make use of the test containers to run the database tests. So now I'm going to create a similar test for the user repository interface. This time I'm going to name the class as user repository test. The configuration is going to be very similar to post repository test class. We have the data JPA test container, and auto configured test database annotations. And inside the test, we are again initializing the MySQL container object, and this time we are auto wiring the user repository. And inside the test method, we have the same logic as the previous test. So we are constructing the user object and saving it to the database and checking whether the actual and expected objects have same values or not. Now let's try to run both the post repository and user repository tests together and see what is going to happen. So you can see that the test took 35 seconds to execute, and the Docker container for the MySQL database is started 2 times for each test. So if I check the logs of the user repository test, you can see that the Docker host is initialized, Docker engine is initialized, and after that it started creating the container for the latest MySQL Docker image. And the same log you can also see in the post repository for the post repository test. So what we can do here is to make sure that the test container is created only once for all the tests which we are executing. So we can do that by using a singleton container pattern, which is suggested by the test container team. So to do that, what we have to do is we have to not use the container and test containers annotation from JUnit 5. Because if we use this annotation, it forces JUnit 5 to restart the test container for each test. And that will make our test execution very slow and unmaintainable. So to get around that, we are going to move all the initialization logic into a base class. So I'm going to create on the root package another new class called as base test. And inside this test, I'm going to copy the logic for the MySQL container initialization. And here, as we are using the singleton pattern, so we have to use a static block to initialize the MySQL container. So if I want to initialize the MySQL container start method, I have to also mark this field as static. So once I mark this field as also static, I can use the MySQL container variable here and use the start method from the MySQL container. In this way, we can initialize the MySQL container only once. And what we have to do next is to make our post repository test and user repository test extend the base test. So after that, we can remove the test containers annotation and also the initialization for the MySQL container from the post repository test. I'm going to do the same thing also for the user repository test. So now let's try to run these 2 tests again and see what happens. So now you can see that the test took far less time than before. And if I click on the user repository test, you can see that the test container was initialized the very first time. So you can see that the test container is starting for MySQL. And if we check the post repository test, we don't see the test container initializing anymore because it is reusing the context, it is reusing the same container. In this tutorial, we are going to learn how to write tests for the Spring Boot REST APIs using Spring's MockMvc. This is the third part of the Spring Boot testing tutorial series, where in the first part we saw how to write unit tests for the service layer of our Reddit clone application using JUnit 5 and Mockito. In the second part, we mainly concentrated on writing tests for the data access layer using Spring Test Framework's Data JPA test and by making use of test containers. And don't forget to have a look at the written companion of this video in the first link in the description section. So without any delay, let's start the video. So if you check the architecture diagram of the Reddit clone application, we have covered the tests for the service layer and persistence layer in the previous videos. Now it's time to concentrate on the presentation layer. So to test the REST controllers which are inside this layer, Spring Test Framework provides us with an annotation called as WebMVC test, which gives access to a specialized Spring context which contains all the beans required to test our web layer, in our case the REST APIs. Let's take a look at this annotation in detail by creating our first test for the post controller class. And inside this class, we have the getAllPosts method with a get mapping, which is returning all the posts which are there inside the application. So if you go inside the getAllPosts method of the post service, you can see that we are just reading all the posts from the post repository, mapping it to the DTO. Now let's go ahead and write a test for this use case. I'm going to create a class called as post controller test. We are going to add an annotation called as WebMVC test. And as we are writing this test for the post controller class, we can provide the class name also to the annotation. And inside the class, we are going to first mock out the dependencies of this post controller class because we are not interested in testing the post service class. So we can mock out the interaction between post controller and post service. To mock the post service class, we don't need to mock each and every dependency of the post service like we did inside the post service test class. I will quickly open the test class. You can see here we are mocking all the dependencies of the post service one by one manually. Instead of that, we can make use of Spring annotation called as mockBean, which will automatically inject the mock objects for the required dependencies for the post service class. After that, we are going to auto-wire another class called as MockMvc, which provides us a way to call our REST endpoints from our test. Mainly provides us a servlet environment where we can make calls to the REST endpoints and it will return us a mock response. Now let's create our first test method, which will test whether the get endpoint will fetch all the posts or not. Inside this test, we are going to call the /API/post endpoint with the HTTP get method. For that, I'm going to type in mockmvc.perform. And inside the method, I'm going to type mockmvc request builder.get. And to this method, I'm going to pass in the URL of our endpoint. And so we are invoking the perform method from the mockMvc object, and we are doing a get call by using this mockMvc request builder.get method to the required endpoint. So when we do this endpoint call, we are expecting a status, an HTTP status OK as a response, so which goes by the value 200. So this is a basic test we can write for our get endpoints. So let's try to execute this test and see what happens. So you can see that the test execution failed. The test is trying to start a Spring context and it is not able to find a bean of type user details service. So in our test, we are trying to mock the post service calls, and this class is using the auth service class as the dependency, and the auth service is using the user details service interface as the dependency. If you remember, we have mentioned that WebMVC test annotation provides only the beans which are necessary for our web layer. But the bean user detail service is part of the Spring security module. So we have to manually mock this bean in our tests. Additionally, I'm going to also mock the JWT provider class, which is also part of the security layer. So now if I try to start the test, you can see that it will run successfully, but there is not much use trying to test the endpoint like this because an endpoint can return a response with status 200. But what we are really interested to see is whether it responds with the data we expect or not. So for that, let's add some more logic to our tests. If you go back to the method getAllPosts inside the post controller, we are expecting a list of post response object as a response from this endpoint. So let's go ahead and mock this method call to the post service and provide this list of post response objects as the response. So inside the test, I'm going to quickly create a couple of post response objects, and I'm going to mock the behavior of the getAllPost method from post service by typing mockito.when post service.getAllPost, then return. And as we are expecting a list, I can type arrays.asList and pass in the two response objects here. So what's going to happen at the time of running the test is whenever this post service.getAllPost method is being executed, Mockito will return this list as a response. So, and here I'm going to add some more assertions to our test. The first assertion is that we expect the response as a JSON. And after that, we are doing an assertion that the size should be 2 because there are 2 objects inside the response. And finally, we're going to make an assertion of individual objects inside the list. So if you run the test, you can see that the tests are executing successfully and we are able to make the assertions on the response which is returned by the AllPost endpoint. So I hope you have learned something about testing REST APIs using MockMvc and WebMVC test annotations by Spring. And please don't forget to subscribe to the channel for more interesting tutorials like this. I will see you in the next video. Until then, happy coding, techies.